Okay, here are our solutions to perfect problem 2 for Math 111. What we're asked to do is find the derivative of this function f of x equals x squared. At this point, you should have no idea what a derivative is. It's not something you learn until Calculus 1. However, we can find it just using methods from our class, actually things we're going over right now. So if you kind of follow these steps, what you end up getting is the derivative. So what we got to do is say, all right, f of x is x squared. And so the two things we're going to need to know are what are f of a, maybe what is f of a, and what is f of a plus h. I find those two things because those are going to appear in my algebraic expression here. So if f of x is x squared, f of a just says change all the x's into a's, so we get a squared. It's not too bad. F of a plus h is a little bit trickier. We want to change the x into an a plus h. So it's now a plus h squared. It's important that you put parentheses in here. We want this entire thing to be squared. And maybe it's worth saying, well, the most common mistake here would be to say, note, a plus h squared is not the same as a squared plus h squared. It's a very common algebraic mistake. Might seem like I'm beating it to death in class, but it's an important thing, and it comes up in a problem like this. In this problem, we wouldn't want to change this to a squared plus h squared. We get the wrong answer. We have to FOIL this thing out. So maybe as long as we're here, we could FOIL it out. We will need to FOIL it out later. A plus h squared is a squared plus 2ah plus h squared. So what we're trying to evaluate is f, maybe I'll switch colors here. We're trying to evaluate f of a plus h, which we now have, minus f of a, which we also have, divided by h. Alright. That is a squared plus 2ah plus h squared, that's f of a plus h, minus f of a squared, all divided by h. And we can simplify this a little bit. We got an a squared and a negative a squared. Maybe cancel those guys out. And so what we're left with here is 2ah plus h squared over h. The next, you might leave it there, although you shouldn't leave it there. It says simplify as much as possible, and we haven't done that. But in case you leave it there, I'll show you how in step 3 you can catch your mistake. In step 3 it says change all the h's into zeros. And so if we try to change all the h's into zeros right now, we'd get 0 divided by 0. Right? We get something undefined. So what we have to do is cancel out this h on the bottom, which we can do. Be careful. A common mistake would be to cancel this h and this h. It doesn't work that way. You can only cancel over multiplication. We have addition up top here. So what you got to do is factor out an h from the top. Note we pulled an h out of both of these terms. This one no longer has an h. This one only has the one h. And now we can cancel out this h up here and this h down here. And what we're left with is 2a plus h. And that's a good thing because we can now evaluate this. Maybe I'll even write it as a sentence, although you don't need to do that. We evaluate 2a plus h at h equals 0 as, what's that, just 2a plus 0 if h is 0, which is equal to 2a. This is our final answer, and this is what's called the derivative of the function f of x equals x squared. It's very important. You'll spend many weeks in a calculus class figuring this out. In calculus, your goal is to be able to find the derivative for any function. We just did it for one function. What you're going to do for an entire quarter is just look at different functions here. Look at any function you can think of and take its derivative. So we get to here. I guess we're all done with this example.